Okay, imagine this. You're streaming the big game, kids are video chatting, the smart fridge is downloading updates. Suddenly, lag. But instead of a panicked router reset, you just download a software upgrade. Boom, problem solved. That's the promise of virtual network functions, VNFs to us techies. And it's not just a futuristic fantasy. There's a whole lot of research going into making VNFs the backbone of tomorrow's networks. Today's deep dive takes us into a 2021 paper towards a virtual network function research agenda, a systematic literature review of VNF. Think of it as a progress report on this networking revolution. Before we get into the nitty-gritty, what exactly are VNFs?
Well, imagine those boxes we used to rely on.
Yeah.
Modems, routers, firewalls. VNS take those hardware functions and turn them into pure software. So instead of a physical box, you have code running on a server somewhere doing the same job, but with the magic of software.
So less clutter, more flexibility. I'm liking where this is going, but what's the real game changer here? Why should we be excited about this?
It's about agility. Let's say you need to boost your network security. Well, with VNFs, you just update the software. No need to wait for a new hardware release or anything like that.
I see.
This means faster innovation, potentially lower costs, and a more responsive internet experience for everyone.
That's huge. But the paper doesn't just stop at definitions, right? It digs into the entire life cycle of a VNF.
Exactly, yeah. Just like any well-engineered product, a VNF goes through different stages: onboarding, scaling, eventual termination. How smoothly it navigates these stages, though, depends on its initial design. And that's where things get interesting.
Like planning a road trip, a well-designed VNF needs to handle all the twists and turns, right? The paper lays out these design considerations. What are some of the big ones we should be thinking about?
Well, location is key. Should a VNF, for example, live in a massive cloud data center for maximum scale, or closer to the network's edge, like a local server room for faster response times, or even on your device itself for ultimate personalization?
So it's about finding the right neighborhood for your VNF to thrive in, each with its own perks and trade-offs, I imagine.
Precisely. The paper really emphasizes how crucial it is to consider these trade-offs from the get-go, ensuring each VNF is deployed strategically.
Okay, so that's location. Next up, we have packaging. Now, this might not sound as thrilling as location scouting, but stick with me.
Oh, it's more exciting than it sounds. Just like apps on your phone come in different packages, so do VNS. You have virtual machines, which are like having a whole separate computer inside your computer, and then you have lightweight containers, which are more like a zip file with everything the VNF needs to run.
So VMs are the heavy-duty SUVs, and containers are the nimble sports cars of the VNF world.
You got it. Choosing the right packaging depends on the VNF's purpose and where it needs to operate. You might not see this directly, but choosing the right packaging makes VNFs run more efficiently, potentially leading to cheaper and faster internet for you.
I like the sound of that. Okay, location, packaging. Now things get a bit more complex with composition complexity, right?
Yeah, think of VNFs like Lego bricks. Some are simple, single-purpose bricks, while others are these complex structures made of many interconnected parts. Naturally, managing a single brick is easier than managing a whole Lego masterpiece.
So some VNFs are like building a quick wall, while others are like tackling the Millennium Falcon. I can see how that would complicate things.
Absolutely, and the paper highlights this trade-off. Simpler VNFs are generally easier to manage and troubleshoot, which is critical for keeping things running smoothly. But sometimes you need that Millennium Falcon level complexity to unlock more advanced functionality.
Makes sense. Now, onto a topic that's close to my heart, fault tolerance. We've all experienced that dreaded internet outage, so how are VNFs being designed to avoid those digital disasters?
Yeah, this is crucial. Servers crash, connections drop. A good VNF needs to be able to handle those failures gracefully, ideally, without you even noticing.
Like a good friend who discreetly cleans up your spilled drink at a party. Always there for you, no matter what.
Exactly. Except in this case, the spilled drink is a network hiccup, and the friend is a piece of software. The goal is seamless reliability. And surprisingly, the paper found that there wasn't a lot of research on this critical aspect of VNF design back in 2021.
Wait, really? That's like forgetting to install airbags in a self-driving car. That seems like a pretty big oversight.
It does raise some eyebrows, and that's what's valuable about this type of research paper. It doesn't just highlight successes, it also shines a light on areas needing more attention.
Gaps, like maybe forgetting to factor in security, which just happens to be the next item on our list.
You're right on track. With great power comes great responsibility, especially when we're talking about software controlling the flow of information.
We don't want our VNFs going all Skynet on us, right?
Exactly. The paper emphasizes the need for robust security and authentication measures, ensuring that these powerful tools are used responsibly.
Okay, so we've covered location, packaging, complexity, fault tolerance, and security. I'm already starting to feel like a VNF expert. But there's more, isn't there? What about those times when the network is busier than a beehive in spring?
You're talking about load balancing, and it's another critical design consideration. It's about ensuring no single VNF gets overwhelmed, even during peak traffic. Imagine if all the shoppers flocked to one checkout lane at the grocery store. Chaos.
So, load balancing is like having enough checkout lanes open to handle even the busiest shopping day of the year.
Precisely. It's about distributing the workload effectively, keeping the network responsive, and preventing those digital traffic jams.
This is fascinating stuff. We've gone from the basics of what VNFs are to the nitty-gritty of designing them for optimal performance. But remember, this paper isn't just about defining these concepts. It's about analyzing the state of research in these areas. And from what you've said so far, it sounds like there were some pretty significant gaps back in 2021.
You're right. The paper identifies several crucial research gaps that needed addressing for VNFs to reach their full potential.
Gaps. Tell me more. What were the missing pieces of the puzzle?
Well, one major gap the paper highlights is the need for more, real-world testing. It's one thing to design a VNF in a controlled lab environment, right? But it's quite another to see how it performs in the wild, dealing with the complexities and unpredictable nature of actual networks.
Yeah, like the difference between a test drive and a cross-country road trip. Lab simulations can only take you so far.
Exactly. The paper's authors, they strongly emphasize the importance of real-world testing to thoroughly understand the strengths and weaknesses of different VNF designs. After all, we want our VNFs to be ready for anything the real world throws at them, right?
Makes sense. So more real-world testing check. What other gaps did they uncover in their research?
Another significant one was the lack of research on distributed deployment. Remember our discussion about location, location, location. Well, back in 2021, most research focused on deploying VNFs in those massive cloud data centers.
Because everything was going to the cloud back then.
Exactly. But as we move towards a more interconnected world, right, with the Internet of Things, edge computing, devices spread far and wide, we need VNFs that can be deployed closer to the edge, closer to where the data is generated.
It's like the difference between having a centralized library and a distributed network of bookstores. Sometimes you need information close at hand.
Precisely. And that's where distributed deployment of VNFs comes in. It's about bringing the network closer to the user for faster response times, more efficient data processing, that sort of thing.
Makes sense. So we have more real-world testing and distributed deployment as two key research gaps. Anything else?
The paper also points out the need for this is a mouthful standardized lifecycle operations for VNFs.
Okay.
Recall our earlier discussion about a VNF's lifecycle.
Mm.
Onboarding, scaling, termination, all that.
Right, right.
The authors, they argue for a more standardized way of managing these operations. Basically, ensuring that VNFs from different vendors can seamlessly work together.
So instead of needing a different instruction manual for each VNF, we need like a universal remote control.
You got it. Standardization is key for interoperability, especially in today's world, where networks rely on VNFs from all sorts of different sources. It's about creating a more unified and efficient ecosystem.
Okay, so we've got our missing puzzle pieces, more real-world testing, research on distributed deployment, and a push for standardized lifecycle operations. But the paper doesn't just leave us with a list of problems to solve, does it? It also examines some real-world examples of VNFs in action, right? I'm always curious to see how theory translates into practice.
Absolutely. The paper actually dives into the world of open source projects to see how VNFs are being developed and used in the real world.
Open source projects. For our listeners who might not be familiar, can you explain what those are?
Sure. Open source projects are basically collaborative software projects where the source code is freely available for anyone to use, modify, and distribute. Think of it as a community effort to build and improve technology.
That's so cool. So what kind of VNF projects were they looking at?
They examine a variety of projects, including some familiar names like OpenVPN. You might have heard of that if you've ever used a VPN for secure browsing.
Oh, yeah, I use a VPN all the time. It's like having a secret passageway for your internet traffic.
Exactly. And then there's Asterisk, a powerful open source platform for building communication systems, like those used for internet calling.
So these aren't just theoretical concepts. These are VNFs that people are already using every day. That's really exciting to see.
It is. And while these projects demonstrate the very real potential of VNFs, The paper also points out that even these popular, widely used projects are still figuring things out, still experimenting and improving their approaches to VNFs.
It just goes to show that even in the world of cutting-edge tech, there's always room for growth and innovation. We're all on this journey of discovery together. So apart from these specific examples, what were the paper's overall findings on the state of VNF research back in 2021?
The paper painted a picture of a field that was, unsurprisingly, still in its early stages. There was a lot of excitement about the potential of VNFs, but also a recognition that there were significant challenges to overcome and areas, as we've discussed, where more research was needed.
A classic case of growing pains for a promising new technology. But it's been a few years since this paper was published. What's been happening in the world of VNS since then?
The VNF landscape has, as you might expect, continued to evolve at a rapid pace. Remember that call for more real-world testing? Well, consider it answered. We've seen a surge in VNF deployments in real-world networks, particularly in the telecom industry, which has been quick to embrace the potential of VNFs.
It's like those VNF seeds that were planted back then have finally sprouted and are starting to flourish. That's amazing to hear.
It is. And we're not just talking about small-scale trials anymore. Major telecom operators worldwide are using VNFs to deliver a variety of services, from basic connectivity to more advanced applications like mobile edge computing and 5G network slicing.
Okay, I'll admit you're starting to lose me a bit with the technical jargon. But the takeaway is that VNFs have gone mainstream in the past few years, right?
They absolutely have. And as VNFs have become more widely adopted, we've also seen significant progress in addressing those research gaps that the paper highlighted.
Like that whole distributed deployment thing.
Exactly. With the rise of edge computing and the Internet of Things, there's been a tremendous push to develop VNFs that are specifically designed for those low-latency distributed use cases. Think of it as bringing the power of the network closer to the devices and users that need it most.
Because who wants to wait ages for their self-driving car to make a decision, right? We need those responses to be lightning fast.
Precisely. And we've witnessed some really exciting advancements in edge-native VNS, specifically built for those demanding, time-sensitive scenarios.
So, distributed deployment check. What about standardized lifecycle operations? Any progress on that front?
Absolutely. Industry groups like ETSI and ONAP have been hard at work developing standardized interfaces and protocols for managing the entire VNF lifecycle. This is a critical step towards making VNFs truly plug-and-play, allowing for easy integration and interchangeability between VNFs from different vendors.
No more need for a stack of instruction manuals. I love it. Standardization is critical for any technology to reach its full potential.
It is. And it's encouraging to see the industry coming together to establish these standards, fostering a more collaborative and innovative ecosystem for VNF development and deployment.
This is incredibly exciting. It's amazing to see how quickly this field is moving and how those research questions from just a few years ago are already being addressed. But before we get too far ahead of ourselves, let's take a step back and remind ourselves why this all matters.
You're right. It's easy to get caught up in the technical details, but ultimately, VNFs are about creating better networks for everyone. They're about making networks faster, more flexible, more adaptable, and ultimately, more capable of supporting the ever-growing demands we place on them.
So VNFs equal better networks for a better tomorrow.
I like that. But, when we think about the future of VNFs and how they might continue to evolve, it raises a pretty intriguing question.
Oh, do tell. What kind of question are we talking about?
Well, if VNFs truly represent the future of networking, if they continue to become more powerful, more flexible, and more accessible,
Yes.
does that mean that anyone could potentially become a network engineer?
Wait, are you saying that I could build a VNF? Me, with my limited tech skills and questionable Wi-Fi password choices?
Well, maybe not you specifically. But in theory, if VNF development becomes more accessible, more user-friendly, who knows what the future holds, maybe someday we'll all be designing and deploying our own custom VNFs, tailored to our specific needs and desires.
That's a mind-blowing thought. The democratization of network engineering. Imagine the possibilities. But that, my friend, is a conversation for another deep dive. We've explored the evolution of VNFs, their design, the research gaps they face, and the exciting advancements that have taken place. But as we wrap up this deep dive, what are your final thoughts on the future of VNFs and their impact on our digital lives?
It really is fascinating to consider how far VNFs have come in just a few short years. We've gone from these kind of niche research projects to a core technology that's powering some of the most advanced networks in the world.
And it's only the beginning.
Exactly.
So where do we go from here? What's next for VNFs? Any predictions?
Well, predicting the future of technology, that's always, a bit of a risky endeavor.
Fair enough. Tech moves faster than my internet connection sometimes.
Right. But one thing is certain, though. The trend towards more flexible, adaptable, and software-defined networks is here to stay. And VNFs are right at the heart of that transformation. So we can anticipate even greater integration with emerging technologies like artificial intelligence, for example, and machine learning. And that's going to lead to smarter, more autonomous networks that can optimize themselves in real time.
That sounds incredible.
Right.
Imagine networks that can predict and prevent problems before they even occur, like having a personal tech support team working behind the scenes 24/7.
Exactly. And this, the self-healing, self-optimizing capability, it's going to be crucial as networks become more complex and handle ever-increasing amounts of data.
It's like those science fiction movies where the spaceship practically runs itself, except in this case, it's the entire internet. Okay, I'm getting a little carried away again. But it's just so exciting to think about.
I share your enthusiasm. And I think it's that sense of wonder and possibility that makes this field so captivating. VNFs are not just about bits and bytes. They're about connecting people, ideas, and opportunities in ways we're only just beginning to explore.
It's like opening a door to a whole new world of possibilities, except this door is made of code and powered by innovation.
Beautifully put.
Thank you.
And as we step through that door, it's vital that we do so responsibly and thoughtfully.
Absolutely. With great power comes great responsibility. Right?
Exactly. As VNFs become more integral to our digital lives, we need to prioritize security, privacy, and ethical considerations. We want to create a future where these technologies empower everyone and contribute to a more equitable and connected world.
Well said. It's a balancing act, for sure. Embracing the transformative potential of VNFs while also ensuring they're used for good.
Precisely. It's a journey we're all on together. And the more informed and engaged we are, the better equipped we'll be to navigate the exciting yet complex future of VNFs and the networks they power.
That's a perfect note to end on. We've covered a lot of ground in this deep dive, from the technical intricacies of VNF design to their profound impact on the future of networking.
Absolutely. We've explored the challenges, the breakthroughs, and the limitless possibilities that lie ahead.
And we've learned that VNFs are more than just a technology. They're a catalyst for innovation, connection, and progress.
I couldn't agree more. It's been a real pleasure joining you on this deep dive today.
The pleasure was all mine. And to our listeners, thank you for joining us on this journey of discovery. We hope you've gained a deeper understanding of VNFs and their potential to shape the future of our digital world. Until next time, keep exploring, keep questioning, and keep imagining the possibilities.